We have completed HCF and LCM in the last class. Probably, I think we have done the previous year questions also. I have done you some 7 to 8 types of previous year questions, okay, which are broadly covering all your various types of questions. We have done that. Today, we'll start with another basic topics. We have 2-3 basic topics using which we'll have to do rest of your topics. So concentrate properly on these topics so we can easily finish off other topics. So we'll be starting with today's square root and cube root. Take a fresh page and write square root and cube root. Another basic chapter. The thing with these kind of chapters is, these small chapters is, you will not get directly questions. But in the one of the sums, you will have this thing. In some other chapter like mensuration and all, this is a very easy topic which can be mixed with any of the topics. I'll give you one example. Let us say we are finding the area of a rectangle. What is the area of a rectangle? What is the formula for area of rectangle?
1/2.
1/2 AB.
No. L into B. L into B. If it is a rectangle, we are supposed to find what? Length, and this is called as breadth. Udda mattu agala. So length and breadth. So area of rectangle is what? L into B. What is the area of square? Area of square is A square. Similarly, area of square will be what? A square. Now, see here, if you look at the question, I will tell you one question. If you look at the question, it will look like as if you have been asking about area, but actually it will be a question of square root. I'll tell you how. If the area of a square is 1296, if the area of square is 1296, what is its side length? Side length is A. So if the area of the square is 1296, what is its side length? Now what will happen? A square is what? 1296? Yes or no?
Yes.
We are supposed to find A. Now from the outset, this question will look like as if they are asking you the area of the square. But what actually they are asking you? They are asking you to find the square root of this number. Yes or no? What is A? A is square root of 1296. Now if you start doing it slowly, then it will take a lot of your time. It will be almost impossible to finish it off within given time. So what will you do now ideally? You have to find some tricks. You have to actually know some tricks so that you can finish it off early. Yes or no? Getting this?
Yes.
Now
Yes, sir.
in this class we'll teach you about all the tricks that are required. How you find square root? How will you find of square root of? You know the square root of prominent numbers. Like what is the square of 1? 1. What is the square of 2? 4. 3 ka kya hai? 9. 4 is 16. But your question will be what will be the square root of 10? Getting this? And you have to find it to the accurate number also. I think by looking at the numbers only, you can tell it will be in between 9 and 16. So your square root has to be 3 point something. Yes or no?
Yes.
That I think you can predict. But the problem is all your options will have 3 point something. Again, you are stuck. So I'll teach you how to find square root, cube root of the numbers which are not a perfect square also. Okay? So we'll start with simple definitions. Write down the heading first. Perfect square. Perfect square. Today I will introduce the topic. Tomorrow we'll solve the sums. I think we may be able to finish it off in the next class. Okay? So write down the first heading. Perfect square. Perfect square. Perfect square is a number. Perfect square is a number. Perfect square is a natural number. You can write it as a natural number. Perfect square is a natural number whose square root is also a natural number. Whose square root is also a natural number. So perfect square is that number whose square root is also a natural number. So what are perfect squares? As I have told you, what is the square root of 1? 2 square root square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 it is 49, 8 it is 64, 9 it is 81, 10 it is what? 100. So these numbers are called as what? Perfect squares. Getting this?
Yes, sir.
For which you can accurately find the square root. As I told you, I gave you the number 10. Can we find the square root of 10? Yes or no? Can we find the square root of 10?
Yes.
We can find it. I'll tell you the rules also, but it will be 3.14 something. I'm not able to recall it properly, but it will be 3.14. Now this is what? This is not a natural number. Understanding? We discussed in the first class, what is a natural number? Natural number has to be what? 1, 2, 3, something of that sort. 3.14 is not a natural number. So this will not be called as a perfect square. So what do we call it then? We call it as non-perfect square. Getting the thing here? What is a perfect square and what is a non-perfect square? Understanding this?
Yes, sir.
Okay. Now write down the heading, properties of perfect square. Write down the heading, properties of perfect square. Write down the heading, properties of perfect square. Now I want you guys to just look at the unit digit. Unit digit is last digit. Whatever is the last digit, that is called as what? Unit digit. So what are the unit digit in our perfect square? 1, 4, 9, 6, 5, 6, 9, 4, 1 and 0. What are the numbers that are missing? First property. What are the numbers that are missing from here? The last digit. 2 is not there. 3 is not there. 4 is there. 5 is there. 6 is there. But 7 is not there. 8 is not there. Understanding here? We don't have 2, 3, 7 or 8. इसका मतलब क्या है? What is the meaning of this? If your unit digit, write the first point. If your unit digit has 2, 3, 7, 8. If your unit digit has 2, 3, 7, 8, then it can never be a perfect square. Understand the rationale here? It will never be a perfect square if it has 2, 3, 7, 8 as your unit digit. Getting this?
Yes, sir.
So one question was asked, I think some 4-5 years back in AFCAT. The question was, identify the, keep writing the question also along with me. Identify the non-perfect square among the following. Identify the non-perfect square among the following. And you had 4 options. Okay, one of the option was 1296. I think then we had one more number. We had this 2025. Then we had 9801. And finally we had 3728. Okay. Now you don't know the square root of any of these numbers because I have asked you to buy at only till 30. Now can you identify which is not a perfect square among these numbers?
Fourth option.
Fourth option. Why it is option 4th? Because I have told you if your unit digit has 8, 7, 3 or 2, then it will not automatically what? Not a perfect square. Not a perfect square. Then it is non-perfect square. Understanding this? Why we are calling it as a non-perfect square and how is it being made here? How is the decision being made? We are concentrating only on the last digit. The unit digit has to contain numbers apart from this to be a perfect square. Getting this? Don't get bothered if the number is very big also. Let us say the number is very big. 4, 5, 6, 7, 2, 1, 8. So is it a perfect square or not a perfect square?
Not perfect square.
Not perfect square. Because it has 8 in the last digit. Getting this? This was your first property. Write down second property. The square of odd numbers are odd and square of even numbers are even. I hope you can see here. What is the square of 1?
Yes.
1. 3 is 9. So square of odd numbers is odd. Square of even numbers is even.
Even.
Then write the third point, but I'll give you the question with respect to that, and I'll tell you how to solve these kind of questions also. This was asked once. This was, I think, probably asked in CDS itself. The difference of squares of two consecutive natural numbers. The difference of squares of two consecutive natural numbers. The difference of squares of two consecutive natural numbers is equal to. Your options are their difference, their product, their sum, and option D was none of the above. Now, whenever you get such kind of questions, what you have to do, these are called as statement kind of problems. It has no mathematical number only. This 2 will also be not written as 2, it will be written as 2. So these are statement related problems. How you have to solve this? I'll give you a very small hint. Whenever you get such things, assume your numbers. What will you assume here now? What will you assume your number as? We'll assume consecutive natural numbers. What is the meaning of consecutive? One after the other. Getting this? Consecutive ka matlab kya hota hai? One after the others. So the difference of squares of two natural numbers. The difference of squares of two natural numbers is what? What is the difference of squares of two consecutive natural numbers here? What are the natural numbers? Natural numbers are these numbers only. Now, if I take the example of 3 and 4, let us say I have taken the example of 3 and 4. What I should do? First, I have to square it. We have to find the difference of squares. This is what is difference of squares. I have to square it, then I have to find the difference. What is 4 square?
16.
16. What is 3 square? 9. What is 16 minus 9? 7.
Yes.
Now, how will I reach 7? By taking the difference. What will happen if I take the difference? What is 4 minus 3? 1. Yes or no? What is 4 into 3? 12. But what is 4 plus 3? 7. So difference of squares of two consecutive natural numbers is equal to what there? Sum. Understanding this? But we have none of the above also as the option. So if it has none of the above as the option, then you have to check at least for 2 to 3 numbers. So I will check for one more number, just because none of the above is the option. So I have to check for one more number. Take any number. I will take 7 and 6. Yes or no? Let us take 7 and 6. What is 7 square minus 6 square? What is 7 square? 49?
49 minus 36.
36. What is 49 minus 36?
35.
13? Yes or no?
Yes, sir.
49 minus 36 is how much? 13. How can I reach 13? By adding these two. 7 plus 6 is how much? 13. Getting this? So whatever we assumed is correct. Now this itself is your third point. What was the third point? The difference between two consecutive natural numbers is equal to their sum.
Sum.
Done?
So
If what they are saying is, what is the statement? Look at the statement here. The statement is the difference of squares of two consecutive natural numbers. Consecutive natural numbers under na one arme one baruvanta number. So consecutive natural numbers, the difference is na ಎರಡು ನಂಬರ್ ತಗೊಂಡೆ ಕನ್ಸಿಕ್ಯೂಟಿವ್ ಅಂದ್ರೆ 3 ಆದ್ಮೇಲೆ 4 ಬರ್ತಿತ್ತಲ್ಲ. ಸೊ 4 ಸ್ಕ್ವೇರ್ ಎಷ್ಟಾಯ್ತು ಅಂದ್ರೆ 16 ಆಯ್ತು. 3 ಸ್ಕ್ವೇರ್ ಎಷ್ಟಾಗ್ತದ 9. ಸೊ 16 ಮೈನಸ್ 9 ಮಾಡಿದ್ದೆ ಅಂದ್ರೆ ನನಗೆ ಈ ನಂಬರ್ ಬರ್ತಿತ್ತಲ್ಲ, ಆ ನಂಬರ್ ಬರ್ಬೇಕಂದ್ರೆ ಆ ನಂಬರ್ಲಿ ಮತ್ತೆ ನಂಗೆ ಕೊಟ್ಟಂತ ನಂಬರ್ನ ಹೆಂಗ್ ಮಾಡ್ಬೇಕು ಅಂತ ಕೇಳ್ತಾರ. ನಾ ಡಿಫ್ರೆನ್ಸ್ ತೆಗಿಬೇಕು, ಏನ ಪ್ರೊಡಕ್ಟ್ ಮಾಡ್ಬೇಕು, ಏನ್ ಸಮ್ ಮಾಡ್ಬೇಕು. ನಾ ಡಿಫ್ರೆನ್ಸ್ ತೆಗೆದ್ರೆ ಏನಾಗತೈತಿ? 4 minus 3 1 ಬರತೈತಿ. ಪ್ರೊಡಕ್ಟ್ ತೆಗೆದಾಗ 4 into 3 12 ಬರಾಕತೈತಿ. ಬಟ್ ನಾ ಸಮ್ ಮಾಡಿದಾಗ ನಂಗೆ 7 ಬರಾಕತೈತಿ. So that's what they are asking.
sir,
They
okay.
are asking difference of squares of two consecutive natural numbers. Done?
Yes.
Can we move ahead?
Yes,
Write
sir.
down next point, fourth one. The product of four consecutive natural numbers. The product of four consecutive natural numbers plus 1. The product of four consecutive natural numbers plus 1 is equal to the product of four consecutive natural numbers plus 1 is equal to, sorry, is equal to tagiri is always ಮಾಡಬೇಕು. Make it as is always. The product of four consecutive natural numbers plus 1 is always a square. Is always a square. The product of four consecutive natural numbers plus 1 is always a square. Four consecutive natural numbers plus 1 is always a square. This is your fourth point. Now, how will you verify this? What is the product of four consecutive natural numbers? Take any four consecutive natural numbers. What are your natural numbers? 1, 2, 3, 4 are natural numbers. So, can we take those numbers? So, it will be what? 1 into 2 into 3 into 4. What is 1 into 2 into 3 into 4? 1 into 2 is 2, 2 into 3 is 6, 6 4, so it is what? 24 plus 1. The product of four consecutive natural numbers plus 1 is always a perfect square, yes or no? Why? Because it is turning out to be 25 and 25 is a square. Getting this? We can check it with any other number also. Let us say we take 4, 5, 6, 7. What is 4 5s are? 20? Yes,
Yes,
or no?
sir.
And what is 6 7s are? What is 6 7s are?
32.
6 7s is 42.
40.
42 2s is 840. Yes or no? Now, if I add 1 to it, it will become what? 841. 841 is a what? Perfect square. Yes or no? Because it is square root of 29. Square of 29 is 841. Getting this? So, this was your fourth point. And final point is fifth point. Fifth point is a number having odd number of zeros. A number having odd number of zeros will never be a perfect square. A number having odd number of zeros will never be a perfect square. So what is a odd number of zeros? In 100, how many zeros we have? We have 2 zeros. 2 is what? Even?
Yes, sir.
Yes or no? But 1000 has how many zeros? 3 zeros.
3.
And
Yes.
3 is odd number. So if we have odd number of zeros at the end of the number, then that number is never a perfect square. Never a perfect square. Understood this point?
Yes, sir.
Okay. Now write down the heading. I'll tell you how to find the square of any number using shortcuts. Let us say you are finding a square of a number. How will you find it? 1 second. What is 13 square? What is 13 square?
169.
13 square is 116. And what is 23 square? What is 23 square? Square is 529.
Yes.
But you started struggling, you are not able to solve 23 square. Then how to solve it using a trick? I'll teach you the trick. Understand this. Here we have what? 13. First I'll square this first number. What is 3 square? 9.
9.
So I'll not write it as 9. I'll write it as 0, 9 because I want 2 digits. So what I'll write? 3 square is what? 39. I'll write it as 0 and 9. What is 1 square? 1 square is 1. So I'll write it
1.
as 0, 1. Okay. Now as you do in your addition sums, you leave this place gap. I leave this place gap using a plus sign. Now what we have? 1 3 is what? 3. I'm multiplying these numbers. 1 3 is 3 and 3 2 is what is 3 2 6.
6.
So my number is what? 169. Getting it? How we solve this?
Yes.
Getting this? Now let us say we have 23 square. How will you find 23 square? First we'll find the square of 3. What is square of 3? 0, 9. And then we have 2 square. What is 2 square? 0, 4. Yes or no? Now we have to multiply it. How will you multiply? 2 3s are. 2 3s are what is what? 6. And 6 2s are 12. Yes or no? I will leave this place. I'll put an addition here. And then it will be 12. 9 plus 0 is 9. 2 plus 0 is 2. 4 plus 1 is 5. Am I getting my number back? 529. Getting this?
Yes,
This
sir.
is the easiest shortcut to find square numbers. Let us say I can do it till 99. I can find the square root till 99. So what is the 99 square? What is 99 square? Try to find it using this method only. This is a good shortcut to solve any of your this thing actually. Squares. If I want to find squares of any numbers, I can use this trick. What is 99 square? 9 square is 81. First I'll take 81. Then one more 9 square is 81. I have to leave this last place. 9 9s are 81. 81 2s are 162. Yes or no? Now I have to add all these digits. 1 plus 0 is 1. 8 plus 2 is 10. 1 plus 6 is 7. 7 plus 1 is 8. 8 plus 1 is 9. So we have 980. Anyways, how to find the square of any number? So take this as homework and find the square of at least 7 to 8 digits. I'll give you the 8 digits. Find the square of 57, 68, 93, 79, 56. Then find the square of 44. Okay, solve all of this and send it back to me after the class. Okay, understood the concept what we did here?
Yes, sir.
So then now write the heading square root. Write the heading square root. Write the heading as square root. I'm just completing the chart. First, I'll teach you the trick. Then we'll look after other methods also, how to find square root, because we want that also. Okay, now look at the unit digits. I write the heading as unit digits. Unit digits in square and unit digits in square root. Unit digit in square and unit digit in square root. Okay. Now look at the numbers. If your square has 1, what will your square root have? This is your square and this is your root, square root. So if your square has 1, your square root also has 1. But we have one more option. What is that one more option? If your square has 1, our square root had 9. Yes or no? If your square had 1, our square root would have had 9. and look for the other number. Second thing, if your square had 4, your square root would have had 2.
2.
But we have one more option also. 4. If there is 4 as a square, then 8 will be its square root. We are just concentrating on the unit digit. Then next. So if your square has, now check the third one. If your square has 9, your square root has 3. And what is one more option for me?
1.
What is one more option for me? 7. Yes or no? So if your square
Yes,
has
sir.
3, your square root has 7.
So,
Then if your square has 6, your square root has 4. And one more option is
4.
6. Understanding this? And
Yes, sir.
finally, if your square has 5, your square root also has 5. And if your square has 0, your square root also has 0. Understand this concept properly. We are talking about only the unit digits here, and we have actually made a list. Copy this list, then we will move further. Okay, let's move on from here. Let's move to the next thing. Now, what will happen? Let us say we want to find the square root of, take any number. Let us say we wanted to find the square root of 729. Okay, you know what is the square root of? We'll do what? Understand the concept properly. This is a shortcut I am teaching you. There is a lengthy method also, then there is shortcut. I'll teach you the shortcut first, then we'll go for the lengthy method, because lengthy method you will use only when the case is different. Otherwise, nobody is checking your rough work, so don't worry about anything. Find the shortcuts, do using your shortcuts. Now what we will do, as we are finding square root, we'll take 2 digits. We'll take 2 digits from the right hand side. So what are my 2 digits from the right hand side? 9 and 2. Then I'll draw a barrier here. Understanding? We started from 9 and 2 and we have drawn a barrier here. Now I'll look at the first digit. What is the first digit here? 7. Yes or no? Now the first digit is, the remaining number is 7. Where will my 7 come? My 7 will come in between what? 4 and 9. Yes or no?
Yes.
My 7 will be in between 4 and 9. So it is coming after the square root of, after the square of 2, and it is before the square of 3. So my square root also should lie in between what? 2 and 3. Yes or no?
Yes.
So I will take my first digit as 2. It has not crossed 9. If it has crossed 9, I would have taken it as 3. As it has not crossed 9 and it is in between 4 and 9, so I will take my first digit as 2. What if my number instead of 7 was 17? What would I have taken it as a first digit? If it was 17, what would have been my first digit? There is some number after this, xy. Let us call it as xy. So if my first 2 digits were 17, what should I take my first digit as? I'll take it as 4, because it is after 16. Getting this?
Yes,
Getting
sir.
how we are solving our first digit? Let us say I have 93, and then we have another number xy. What will I take my first digit as?
9.
I'll take it as 9, because it is after 81. Understanding the concept here? Understanding the first
Yes.
digit, how we are taking first digit is very easy. The problem is in second digit. Now while solving for the second digit, now look at the last digit. What is the last digit here? 9.
29.
9. Only we are talking about the last digit. Last digit is what? 9. Yes or no?
Yes.
Now look at the table. If my square had 9, what are my options? My options were 3 and 7. Yes or no? My options were 3 or 7. Now look at the number 29. Where is it? 29. Where will it be? 29 will it be in between 25 and 36. Yes or no?
Yes, sir.
29 will be in between 25 and 36. Now we have to check whether it is closer to the number below or whether it is closer to the number above. Matlab 29 is in between 25 and 36. So is it closer to 25 or is it closer to 36? How's it?
25.
How's it? The meeting will end now. Please rejoin. I'll start with the same. Okay, we'll start off from the initial. Sorry for the disturbance. We'll start. We had started with the number 729, and we have started from the right side, and we had made a grouping of 2 numbers each. So we have made a grouping of 2 numbers each, 2 and 9. Now what we have? We have 7. Where will 7 come? 7 will come in between 4 and 9. Yes or no? 7 will come in between 4 and 9. As it is after 2's square, so I'll take the first digit as 2. Okay. Now first digit is fixed 2. Now we have to, I did it for 25 and 36. Don't do it for 25 and 36. It will be lengthy back then. Do it, do using this. For second digit, what I'll do, I'll check whether 7 is closer to 4 or 7 is closer to 9. When my last digit is 9, I have 2 options. What are my 2 options? 3 or 7. Understanding this? If my number is 9, last digit is 9, so my options are what? 3 or 7. Now I will look at this 7. 7 is closer to 4 or 7 is closer to 9? 7 is closer to 4 or 7 is closer to 9? From 7, it
9.
will be closer to 9. So 9 matlab I have to take the digit which is below. So I'll take it as 27. Understanding what we did here? I'll explain again. From the right side, we made a grouping of 2 numbers each. Then we found out that it is 29. So when I went for my first digit, it was 7. 7 will come after the square of 2. 2 square is 4, so it will come after that. So my first digit is fixed as 2. My second digit is, I will find out the unit digit and then I'll take the condition. What is the condition here? If 9 is the square, then square root will have 3. It has 2 options. One is 3 and one more is 7. Now I'll write 4 and 9 because 7 is in between 4 and 9. If it was closer to 4, then I would have taken 3 as the last digit. But it is closer to 9, so I'm taking 7 as the last digit. Getting this? We'll solve 2-3 more examples, then you may be able to understand it better. Okay. Let us take the example of one more number. Let me just erase this before we take one more number. Let us take the example of any number you can think of. Let's start with simple ones. 256. Okay. What is 256? 256, we have to start from the right side. What is the right side? Right side, we have to take 2 digits. So we have taken out 2 digits. 2 digits are 5 and 6. Now I look at my first digit. 2 will come after what square root? It will come after 1. Yes or no?
Yes, sir.
2 will come after 1. So it is before 4 and it is in between 1 and 4. Getting this? So I'll take my first square root. What is the square root of 1? 1.
Yes.
First digit is fixed. First digit, I don't think so anybody has problem. Now look at the second digit. Second digit, what are my options? If it is 6, what are my options? 4 and 6. Getting this? My options are 4 and 6. Now I will check whether this 2 is closer to... No, sorry. Say, na? Yeah, it is correct. Now I'll check whether...
Correct.
Hello.
Hello, sir.
Am I audible or is it gone?
Yes, sir. Yes, sir.
I'm audible, right?
Yes,
Yes.
sir.
Okay. I think 1 second. We'll take a bigger example. Let's take a bigger example, whatever you can suggest. What is the square of 57? Can you find it using this method? This is square of 57. 7 square is 49. 5 square is
29.
5 square is 25. So if I add them, 5 7s is what? 35. And 35 2 is 70. Getting this? 35 2 is
2949.
yes. Square root is 9 4. 5 plus 7 is how much? 5 plus 7 is how much?
12.
12.
Yes. It is what? 3 2 4. Getting this? Now we'll find the square root of this number. Because we have found out the trick to find square root, so I'll find the square root. देख लो यहाँ पे 3249. From right hand side, I have to make a grouping of two numbers each. So it will be what? 49. Getting this? Now this 32 is in between 25 and 36. So for
36.
first digit, I have to find the square root of the upper number. What is the square root of upper number? 5.
5.
So yeah. Now I have two options. What are my options? For 9, I have two options. What are my options? 3 or 7?
1. 7.
3 or
7.
7.
7.
Now I'll check whether 32 is closer to 36 or 25. 32 is closer to 25 or 36.
36.
It is closer to
36, sir.
36. So I'll take my last digit as 7. Understanding the trick here? I am teaching you both the tricks
Sir.
here. Finding the square as well as finding the square root also.
Yes, sir.
Okay. Now let us take one more example before we finish it off compulsory. I think we found out the square root of 99. Sorry, square of 99. What was the square of 99? We got it as 9801. Yes or no? We got it as
Yes, sir.
9801. So what we'll do the grouping from right hand side. What are the groupings? Two numbers ka group. We have 01 and 98. So when we have 98, what are my options? My options are 81,
9.
100. And यहाँ पे
100.
last digit options are 1 and 9.
1. 9.
Getting this? For first digit, what
Yes,
should
sir.
I do? For first digit, I have to find the square root of the upper number. What is the square root of upper
Yes.
number? 9.
81. 9. Yes.
Getting this? For second digit, I have to search whether it is closer to 81 or whether it is closer to 100. What is it?
Huh.
For what it is
100,
closer?
sir.
100. So I have to take the digit which is at the bottom. Getting this? How we are solving?
Yes, sir.
Okay. So take it as homework. Solve some 7-8 sums. Find the square root of 4096. 4096. Find the square root of 3025. Find the square root of 1521. 8649. And 624. Find the square root of all these numbers. I think you can manage this.
Yes.
Now write the heading cube root. For cube root also the trick is very similar. First we'll write the list. What is the list? What is the cube of 1? 1. 2 cube is 8. 3 cube is 27. 4 cube is 64. 5 cube is 125.
125.
What is 6 cube?
144.
6 cube is 216. 6 cube is 216. What is 7 cube? 343.
343.
Yes. What is 8 cube?
529.
512.
5.
What is 9 cube? 9 cube is 729.
Yes.
Okay. Now look at the unit digits. Here it is very easy. Unit digit concept here it is very easy, and to find the cube root also it's very easy. Now we look at the cubes and their roots. We are talking about only unit digits here. If the cube has 1, your unit digit had 1. No other numbers have 1 as the cube root itself. And if your cube root has 8, sorry, cube has 8, then your cube root will have 2. If
Yes.
your cube has 7,
Yes.
your cube root will have 3. If
3.
your cube has 4, your cube root will also have 4.
4.
If your cube has 5, your cube root will also have 5.
5.
If your cube has 6, your cube root will also have 6. If your cube has 3, your cube root will also have, sorry, your cube root will have 7.
7.
If your cube has 2, your cube root will have 8. And if your cube has 9, it will have 9. And if your cube has 0, it will have 0. Understanding
0.
this? It's very
Yes,
simple.
sir.
Apart from 2, 3, 7, 8, the rest of the numbers are same. For 4 we have 4, for 5 we have 5, for 6 we have 5, 6, like this. Only for 2, 3, 7 and 8 it is interchanging. For 2 we have 8, for 3 we have 7, for 7 we have 3, for 8 we have 2. Getting this? Now let us say we are supposed to find the cube root of any number. Let us say we are supposed to find the cube root of, take down, we want to find the cube root of 3375. When we were doing it for square root matlab it has 2. It has 2 digits. Square itself matlab 2. So no, but we are cube root means 3. So from right I'll take 3 digits. What are my 3 digits? 1, 2, 3. I've drawn the line here. Now 3 is in between what? 3 is in between 1 and 8. So no, 3 is in between 1 and 8. So my first digit has to be 1.
1.
Because we have to find the cube root of the first number. Cube root of first number is 1 here.
1.
Now we'll check for the last digit. What is the last digit? 5.
5.
When we have 5, what do we have here? We have 5. All simple.
5.
So your cube root will be 15. Understanding the logic, what we are doing here?
Yes, sir.
It's pretty easy for our thing also. Now let us say we had one more thing. Solve it by yourself. 1756. 1756. Solve it. Tell me the answer. What you getting? How much you're getting? 17576. From the right hand side, we have to make a grouping of 3 digits 1, 2, 3. So this is a grouping. Then for 17 will come after what? 17 will come after 8 and before 27. Yes or no? Now we have to find the square root of first digit. What is the square root of, sorry, cube root of first digit? What is the square root of this digit? 2. That will be our first digit. We have fixed the first digit. Now 6. When will we have cube root as 6? If cube has 6, cube root will also have 6. Getting this? It's very easy. If you do it like this, it's very easy. Getting this?
Yes, sir.
Okay. This was about cube and cube roots. I'll give you a few more examples. Take down and find it. Find the cube root of 140608. Find the cube root of 35937. Find the cube root of 54872. Solve all of this and send it back. Okay.
Yes, sir.
So I've taught you both the tricks. I've taught you the trick to find cube also. I've taught you the trick to find out cube root also, square root and square also. Now let us go by your actual method, which is required for some of the sums. Write down the heading, methods of finding square root. Write down the heading, methods of finding square root. Methods of finding square root. First method is prime factorization method. First method is prime factorization method. Now what we do in this method? We'll take a number, we'll divide it using your HCF LCM concept. That's why I started with HCF and LCM, because that is a very important thing. So let us start with your prime factorization method. Let us start with your number. Let us say my number is 1296. So I'll start dividing it with 2. What will I get if I divide by 2? What will I get if I divide 1296 by 2?
2 4s, sir.
2 6 it is 12. 2 4s are 8 and 1 is left, it will become 16. So it will be 648. What is 648 divided by 2? 324. Yes or no? If I divide further by 2, 2 6 2s, again I'll divide by 2, 2 8s, 2 1s, then I'll divide by 3 because I cannot divide it by 2, 3 27s, then again I'll divide by 3, 3 9s. Yes or no? So 9 I'll take and then I'll divide by 3 3s, 3 1s. This is called as factorization of a number. So what we have done, we have started from 2, then we have reached till 3. Now what I'll do, I'll take all the factors. 1296 can be written as 2 into 2 into 2 into 2. So how many 2s are there? 4 2s are there. And we have to write 4 3s also. We have 4 2s and we also have 4 3s. Now what will I do? For finding square root, I'll take 2 numbers each. So what are my numbers? I'll take 2 numbers as 2 and 2. What is 2? In these 2, I'll take 1 2. And these 2, from these 2, I'll take 1 2. From these 2 3s, I'll take 1 3. From these 2 3s, I'll take 1 3. So what is my answer now? I have to multiply these things. What is 2 2s are? What is 2 2s are? 2 2s are is
4,
4.
sir.
4. And 3 3s are is 9. What
9.
is 4 into 9? 36.
Yes.
Yes or no?
Yes, sir.
This is prime factorization method of finding a square root. I'll explain again what we did. We started with a number, we divided it, we found all the factors. Then we started pairing the factors. We had 2 2s, I took out 1 2. We had 2 3s, I took 1 3 from it. Like this, we started pairing it and eventually we got to the result, which is 36. Getting this, what we did here?
Yes, sir.
This is how you find using prime factorization method. So copy this down. Then we'll find the
Yes, sir.
square cube root also using the same method. let us find the next. Let us find the cube root of one number using prime factorization methods. Let us take the example of 13824. What I have to do? I have to divide by my convenient number, whatever my number is. I'll start with 2. So what is 132,824 divided by 2? 2 6 are 12. 2 6 it is 12. And I have 1 as the remainder, it will become 18. 2 9s are 18. Then we have 2 1s are 2. Then we have 2 2s are 4. Then again I'll divide this same number by 2. Total I get 2 3s are 6. 2 4s are 8. 1 is the remainder, it will become 11. 2 5s are 10. 2 6 are 12. Getting this? Then again I'll divide by 2. What will I get? I'll get it 17 and 28. Then again if I divide by 2, what will I get? I'll get 2 8s are 16. 1 is the remainder. 12 हो गया. 2 6 are 12 and 2 4s. Yes or no? I'll divide it again by 2. How much I'm getting? I'm getting 432. Then I'll divide it again by 2. What will I get if I divide by 2? It will be 216. Now I'll take 216. Then I'll divide it by 2 again. What will I get? I'll get 108. Then again by 2, I'll get 54. Then again by 2, I'll get 27. Then again by 3. Because I cannot divide by 3. Sorry, 2. Then 3 3s are. And finally 3 1s are. Getting this, what we did here, we have taken down your number and we have broken it into smaller pieces. Now I'll group 3 numbers because we are finding cube root. So I'll take 3 numbers each, 3 pairs. So we have 3 2s. Out of that, I'll take 1 2. We have 3 2s, then I'll take 1 2. We have 3 2s, we'll take 1 2. And we have 3 3s, I'll take 1 3. Getting this?
Yes, sir.
So what is my cube root now? I have to multiply only these numbers. 2 2s are 4, 4 2s are 8,
4.
8 3s are
8.
20.
4.
Getting this?
Yes, sir.
Why I'm teaching you this method, I will let you know, but understand what we are doing right. It is 13824. Yeah, done with it?
Yes, sir.
Okay. So why we are doing this? The question will be, write on the question. Why we are doing prime factorization? What should be multiplied to? What should be multiplied to? What should be multiplied to? 2048. What should be multiplied to 2048 to make it a perfect square? To make it a perfect square. Right now it is not a perfect square. So the question was, what should I multiply it with to make it a perfect square? Why is 2048 not a perfect square? Because it has 8 in the unit digit. Getting this? Both sides. As it has 8 in the unit digit, so it will not be a perfect square. So what should be multiplied to 2048 to make it a perfect square? So what will I do? I'll start using my prime factorization. I'll start dividing it. 2 10s are and 2 2s are 2 4s. We have reached 1024. Then it is 2 5 1 2. So then it is again 2 2 2s are 4. 1 is left 11 ho gaya. 2 5s are 10. 1 is left 12. 256. I'll divide by 2 again. So I'll get what? 128. So now 1 2 and 8. Then I'll divide it by 2 again. I'll get what? 64.
64.
As soon as you get a number for which you know the square, then do it directly. How will you do it? We'll write it as 8 8s are. Yes or no? So then it will be 8 1s are. So do it only till you get a perfect square. So we got a perfect square which was a 64. You could have done it here also. What is 256? 256 is 16 16s are. Yes or no? We'll not find the actual factors. We'll find only the squares. So I can write this entire thing as how much I'm getting. I can write this entire thing as 1 second. Oh, I'm getting how many numbers? I'm getting 2 into 2 into 2 into 2. How many 2s are there? 5 2s are there. And then we
Yes,
have
sir.
2 8. Getting this? Now I
Yes,
have
sir.
2 pairs of 8, so I'll take out 1 8. I have 2 pairs of 2, I'll take out 1 2. I have 2 pairs of 2, I will take out 1 2. But there is only one pair of 2. What will you do now? We don't have one more pair, no? We should have 2 pairs to find out the square. To make it a perfect square, we should have 2 2s. But we have only 1 2. So what will be the number I'll be multiplying it with? I'll be multiplying it with 2 to make it a perfect square. Getting this? Why we are multiplying it with 2?
Yes, sir.
So this is what the method is. Copy it. We'll do one more. Okay, let us take one more example. Same thing. What should it be? Matlab, let us say if it is multiplied, then we have to give it. If it is divided, we have to take out from. Okay, understand this concept. What should be multiplied to 125 to make it a perfect square? Instead of multiplied, write this time divided. What should be divided? By what number should 125 be divided? By what number should 125 be divided to make it a perfect square? By what number 125 should be divided to make it a perfect square? So 125, what we will do? We will divide it by 5. If I divide it by 5, how much I'll get? 5 2s are 10. 2 is the remainder, it will become 25. So 5 5s are 25. Then we have 5 5s are. And then we finally have 5 1s are. So how many numbers are there? There are 3 numbers. 5 into 5 into 5. Yes or no? We can take a pair of 2 5s, but there is this 1 5 which is extra. So if you are multiplying also, we have to multiply another 5, or we have to take out this number completely. If I take out this number completely also, it will become a perfect square. If I multiply 5 to it also, then it will become perfect square. Understanding this? So
Yes, sir.
write down a note over there, write a note below it. The number to be multiplied or divided will be same. If the question is multiplied also, the answer will be same. If the question is divided also, the answer will be same. Multiplied also, the answer will be same. Divided also, the answer will be same. Okay. Then if the question was for cube root, then the answer will change. Only in the case of cube root, the answer will change. What will it become if it is cube root? Let us say we are finding the cube root of 620. Let us say we are finding the cube root of 625. The question is, what should be multiplied to? Write the question. What should be multiplied to 625 to make it a perfect cube? What should be multiplied to 625 to make it a perfect cube? What should I multiply it with? First, I will divide it by 5. So it will become what? 5 ones are 5. We are left with 1. 12 okay. So 5 twos are 10. We are left with 2. So 25. 5 5s are 25. Then again it is same. The one what we did earlier. 25. 5 5s are 5 1s are. Getting this? Now if I write it, it will be 5 into 5 into 5 into 5. Now we are supposed to find cube root. So I will take 3 digits. So this will be 1 5 out of 3 5s. Out of 3 5s, I have to take 1 5. So this 5 is extra. Getting this? This 5 is extra.
Sir.
If the question was divided, the answer would have been, what should be subtracted here? What should we take out from here? We should take out 5 from here. Yes or no?
5, yes. Yes.
So if the question was divided, we could have taken out 5. And if the question is multiplied, then I have to give what? I have to give 2 5s.
Yes.
Because we want pair of 3 numbers. So I have to give 2 5s. So it will be what? Into 5 into 5. Getting this? So it will be into
Yes, sir.
5 into 5. So if the question is multiplied, the answer will be 25. 5 into 5 is 25 basically. If the question is divided, the answer will be 5. Getting the difference? What we are doing here? You'll get
Yes,
these
sir.
questions. What should be multiplied? What should be divided? You'll get such kind of questions. Okay. This is prime factorization method and the examples on it. But if nothing is given, matlab they are not specifically asking anything, then what method will you use? If they are not asking anything, what method we will use? If they are not asking anything, then we'll use our shortcut. Getting this? If they are just asking what is the square root or what is the cube root, then we'll use our shortcuts. If they are asking what should be multiplied, what should be divided, then we'll use our prime factorization. Then there is one more concept called as what should be added and what should be subtracted. For this, we'll use one more method. I will teach you in the next class. Okay. Now, before
Yes,
we
sir.
wind up today's session, do one sum. One very simple sum. We can do this. Finding the square root and cube root of decimals. Take down the heading. Decimals. Decimals. Decimals in that first square root. We can finish out this. First heading is square root. So what we will do, let us say we have a number called as 12.96. So what will be the square root of 12.96? We just figured it out. It was 36. So now, first what we will do, see the number here. First what we will do, we will take the number as it is. What is the number without the decimal? What is the number without the decimal? The number is 1296. Yes or no? Without the decimal, the number is 1296. Then we'll find the square root of it. We have shortcut, we have prime factorization method. Choose whatever method you use. We used the prime factorization method and we found out the square root to be 36. Yes or no? We did this in 2-3 sums before. We did this concept where we found out the square root of 1296, which was 36. Now what will I do? I will count the number of digits after decimal. So how many digits we have after decimal? We have 2 digits. Whatever the number of digits is, we have to divide it by 2 because we are finding square root. Square itself means 2. Getting this? So I will divide it by 2. What will I get if I divide it by 2? I will get 1. So how many digits should be there after decimal? After decimal, we should have 1 digit. So I will leave this thing and I will mark a decimal unit. So what is the square root of 12.96? It is 3.6.
6.
If the number was 0.1296, what will we do? If the number was 0.1296, now we will find the square root of 1296. It is 36 again. Yes or no?
Yes.
We'll take out the decimal, then we'll find the square root, as if decimal was not there. The square root would have been 1296. Now, how many digits we have after decimal? How many digits we have? 4. I will divide by 2 because we are finding out the square root. So, how many decimals should my answer contain after the decimal? Should have 2 digits. 4 by 2 is how much? 2. So, 1, 2, then I will place a decimal. So, your answer is 0.36. Understanding what we are doing here? If your question was 0.001296, again same procedure. Behave as if there is no decimal point. If there is no decimal point, my number would have been 1296 and its square root would have been 36. Yes or not? Now I will count the number of digits after decimal. How many digits are there after decimal? 1, 2, 3, 4, 5, 6. This 6 I have to divide by 2. What will I get if I divide 6 by 2? I'll get 3. So my decimal should have 3 digits. After decimal, my number of digits is 3. 1, 2, third is not there, so I'll place a 0. So my answer will be 0.036. Getting this?
Yes, sir.
This is how you find a square root of a number, decimal number. In cube root, we'll the same procedure. Everything is same in cube root. Just this number, instead of dividing it by 2, we'll divide it by 3. We'll divide it by what? 3. Okay. So take any cube root which we have actually figured out. Let us say we will take the cube root of 27. What is cube root of 27? I'll give the answer. Don't worry. In either exam also they will give it. They will give it like this. If cube root of 19683. If cube root of 19683 is 27, then what is the cube root of 0.019683? Then what is the cube root of 0.019683? Now we have to do what? We know the cube root of 19683 as what? 27. Now we have to count the number of digits after decimal. How many digits are there? 1, 2, 3, 4, 5, 6. So 6 has to be divided by 3. What is 6 by 3?
3.
2.
2.
So my number of digits after decimal has to be 2. 1, 2. My answer is 0.27. Getting this?
Yes, sir.
This is how you find the cube root of decimals. Okay. So do all the homeworks. We'll meet again tomorrow with one last concept of square root, and then we'll solve some sums. Okay. Thank you.
Yes, sir. Thank you, sir.